Alright, we're gonna go over chapter 1, multiple choice questions for David Morin's book. So basically for these kinds of problems, what you want to be able to focus on is being able to get the unit of what you're trying to look for and just basically calculate the units for every single other answer. That's basically the idea of dimensional analysis. So yeah, let's just start with 1.1. So I'm gonna list out the answer choices first because that's kind of the only way we're going to be able to get our answer. I think it's the only way. I don't know if there's another. Just the way I do it. And so things we have here are kind of like standard units. So, all right. So that's what we have so far. First, I'm gonna define some stuff. So A equals acceleration. Sorry for the handwriting. T equals time. M is equal to, let's see, mass, velocity, which is v. The last one we have, I think, is, let's see, L, which is length. Now, so for the purpose of these videos, I'm going to introduce some other units. So for acceleration, we know that's meters per second squared, right? For time, I'm going to say this is seconds. For mass, I'm going to say kilograms. I'm going to abbreviate it with kg. And for velocity, that's going to be m over s, meters per second. And for length, I'm going to say meters because, again, meters is what we're using for everything else. So it's just going to be easier for us to calculate. All right, that's all we need. And again, you can use this, kind of the same method for every other problem. So for first A, I'm going to leave it right down here. A, we know, is dv over dt. And let's actually look at the question here. It says, if the task of a given problem is to find a certain length, so which of the following quantities could be the answer? So basically, if we're trying to find a certain length, we're trying to find m. So if our final unit is m, then that's basically how we're going to solve the answer. So a equals dv over dt, right? That's baseline number 1. So we have basically something like v over t times t. And so we have v as our final answer. Now v is nothing like m, so wrong. A is wrong. B is mvt. And that doesn't really make sense. Because if you abbreviate m, right, which is mass, as you define here, that's kg times meters per second times seconds. You cross that out and we get kilograms times meters. And again, that's not what we're looking for because we have an extra kg. So no, that's wrong. So let's go to C. Rad AL. Rad AL is the same thing as rad, and I'm going to put this in parentheses because you always want to do that. M over s squared times m. Because it's meters length, right? We're trying to use meters instead of length for just personally, that's what I want to do. So now we have something like this. Meters squared over s squared. Now we have a square root here, so I'm going to make it a little bit easier for us to see this. So those things cancel out, and we get m over s, which is the same thing as v, right? But that doesn't matter because we're looking for m once again, so this is wrong. And so we only have 2 options left. Hopefully this is the one so we can stop doing this. V is m over s in parentheses divided by seconds, and now we have m over s squared. Notice how this is v over t, right? The same thing we defined earlier, if we look over here, as acceleration. And as we see, right, this is m over s squared, so obviously my units are correct. So this is wrong, unfortunately. So, and obviously this with E, this has to be the correct answer. But let's just do this for fun to really see why this works. V is squared over A. We have V m over s squared over A, and we know A is m over s squared. Now I think you know where this goes. That equals m squared over s squared times s squared over m. We take that out and we get something like m. Boom, bam, bing. That's our answer.